Constructing a transformer. The transformer is an electrical component designed to change the level of voltage and current according to need. Operation. Electronic devices used to operate at different voltage levels delivered by the public. To operate these devices require a transformer. A transformer consists of a core of laminated silicon iron on which is wrapped a coil of insulated copper wire called magnetic wire. The first coil receives power from the grid. This coil generates a magnetic field which induces a motion of electrons in the second coil, producing a different voltage and current at the output. The difference of turns of wire between the primary and the secondary coil creates a proportional difference between the input voltage and output voltage of the transformer. The processor that we will build in this case is 18 to 18 volts AC, ideal for the amplifier of 300 watts. We teach to build it on our website construyasuvideorecola.com. Materials: double-layer magnet wire. Copper wire is coated with the electric varnish used in the manufacture of generators, alternators, coils, electric motors, power transformers, etc. Silicon iron sheets. These silicon iron sheets come in the shape of the letter I and the letter E in their per sheet, forming the core of the transformer. Wax paper or pressboard. This roll is used to isolate the windings or coils of wire together. It has a paraffin bed which makes it flexible and ductile. It also seals out moisture and gives heat resistance, preventing from crystallizing. Masking tape. It is used to hold paper and wire between the windings. Foot screws and squares. The screws used to tighten the plates of iron, and squares or brackets are used to adjust the transformer to the chassis or cabinet. Formwork. Square one reel is used as support for winding the wire and prevent spreading, helping the smooth narrow of the wire. The formwork are available in various materials such as plastic, cardboards, and fiberglass. The Geometer Jaime Rio's 7 planes design formwork, which may be downloaded from our website and then build them in straw or cardboard. It must make the pieces of cardboard gluing with the glue for wood, reinforcing with masking tape and coat of varnish which protects the reel from moisture, giving it consistency and durability. Calculation of transformers. Before the construction of a transformer, you should study our article on how to calculate a transformer. To calculate the number of turns of wire, we take the core area as the product of multiplying side by side of the mold. In this case, we have a formwork of 5 by 3.8 inches, which gives us a core with an area of 19 square centimeters. We take the constant 42 and divide it by 19 for 2.21 turns per bolt. As on the public of our country, we have a voltage of 115 volts multiplied by the number of turns per bolt. Now we know how many laps given in the primary winding. For the secondary winding, in this case 18 volts, multiplied by the number of turns per bolt, and 40 turns of wire get doubles. Construction. We drill the mold where you will enter one end of the primary winding wire. Setting the magnet wire. We remove about 5 mm rubber coating. Pre-tying the type of cable, joining welding, soldering iron and workpiece at the same time. It is necessary to sand a few millimeters from the top of the tip of the wire to remove the varnish layer, the electric isolation from the electric and moisture. Pre-tying wire tip copper. We connected the wire and cable, melting the solder with the soldering iron. Use thermal shrinking isolator 3mm to isolate the joint. This heat thermal shrinking isolator isolates and takes in the form of what it covers. Insert the wire through the hole. The wire is secure considering leaving the union within the mold. Secure the wire with masking tape. Winding the wire. Grab the wire of the primary winding from bottom to top, from left to right, pressing well and taking care not to ride around on another and no spaces between the turns of wire. This is done in an orderly and neat to fit all necessary turns. We recommend that every 100 turns of wire, stick a piece of tape with the number of revolution and sew. If you lose track of laps, only to be returned to the last tape recorded a number of turns. When you finish all the laps winding the primary winding, cut the wire. We remove the dielectric varnish using a piece of sandpaper. We took a piece of wire and 5mm retired covering coating. Thin the tip of the cable. Thin the tip of the wire. And join the cable and wire with the soldering iron. We cover the union with thermal shrinking isolator spaghetti 3mm and apply heat. Insert the cord into an outlet slot. Isolating the primary winding. The primary and the secondary windings are isolated from each other with masking tape and waste paper or pressboard. The wax paper should cover the entire wire and secure with masking tape. Then, the paper is covered with more tape. Make sure there are no spaces through which they can touch the primary with the secondary winding. Ensuring the secondary winding. To wind the secondary winding, as in this case is a central tap transformer, wire is wound twice. Secure with tape masking and roll from left to right, pressing well and taking care not to ride around on another and no spaces between the turns of wire. At the end of winding, cut the wire and insert the tips of the tail end of the wire in the output slots. We sand the ends of the wire to remove the dielectric isolating layer of varnish. Detecting the central tap of the transformer center point. We must identify the ends of the windings measured continually with a multimeter. It is necessary to join leading edge of a winding with the tail of another winding. The starting point of a secondary winding must together with the tip end of the other secondary winding, thus forming the central tap. In order to weld the central tap point or center, remember to sand the pieces of wire so that there is adhesion of the solder and good driving. Recheck in continuity with the multimeter, which has a conduction between the three tips of the secondary winding. it is very important to be sure to correct binding center point. For this we must remove the 2 wires and remeasure. There should be continuity between the 2 wires. Again, covering with masking tape and waste paper. The secondary winding must be completely covered. The additional winding is 12 volts. To find the turns of wire, 12 volts multiplied by the number of turns per volt. The result is 27 laps for the additional winding. This winding fits a preamplifier which will complement the saving amplifier put another transformer. Like the previous windings, it's necessary to weld a wire to copper wire and masking tape on to roll the additional winding. Wire is wound down up to adjust the point of beginning with the turns of wire and finish up. For this transformer we only need 27 laps, which are the result of multiplying 12 by 2.21 volts turns per volt. At the end of winding turns of wire for the additional winding, top weld wire plastic coating wire. Remember to sand the tip of the wire. Weld it to the cable and isolate with thermal shrinking isolator. At the time of the action of the transformer is covered with tape again, isolating the additional winding. Then, with a piece of waxed paper or pressboard, we straighten the part where the wires join the main secondary winding, with the output wire. We sand the ends, removing the dielectric coating, allowing the adhesion of the weld tightening tips. And the cable braid thinning over the wire. Now apply plenty of thin until completely cover the cable. The welds must be perfect, since these depend on no loss of current. We cover the junction with thermal shrinking spaghetti so that fully cover the welds. Impression cable joins with wire on the front of the transformer. We put a piece of wax paper covering the joints and secured with masking tape. To give a good finish to our transformer winding is covered with a strip of cardboard coated with adhesive paper. Placing the iron silicone sheets. Now comes the process of placing the sheets or sheets of iron silicone. We shape plates E and we introduce into the mold, sandwiching on one hand and the other on the other side. Be careful not to lock them or feet of 2 or more sheets stick together. The total number of plates or sheets that requires a transformer saturation is defined, then so be introduced until there is no space to introduce one more. To ensure a good fit between plate and sheet, it usually is done by hitting with the hammer. Now we place the complement of the plate E, which are shaped plates I. These are intersplit in the gaps between the backs of the plates E. Final adjustment of the plates. After installing all the plates, we will fit together. Place the transformer on a hard flat and let the hammer correcting its location, until all the faces look perfectly flat. Measurements. Series circuit. This system allows testing electric circuits without the risk of burning. If the circuit is in short, the bulb turns on. If the circuit is not shortened or open, the bulb does not light. Place the two cross-clip circuit series at both ends of the transformer input current. Series circuit must not ignite. To verify that the windings are not open or interrupt, rows along with the tips of the secondary winding and the bulb will turn on. Do the same with the tips of the additional winding. If the windings are correct, the light bulb in every case must turn on. Now connect the transformer to the outlet. With the multimeter on AC voltage scale, place one end on the right end on the secondary winding and the other in the central tap. You should mark the desired voltage, in this case 18 volts AC, as well as between the left and central tap. Measure between the two ends of the secondary winding. You should mark twice, in this case 36 volts AC. The additional winding must dial the desired voltage, in this case between 12 and 13 volts AC. Finishes. For aesthetics, we recommend painting the plate with an oil-based paint, so we get an optimal transformer and good looking. Place bolt. To avoid vibration, cross through bolts with a nut and washer on the two corners of the transformer and squeeze very hard to get a solid piece. In the two lower corners of the screw, replacing washers per metal brackets. These serve to hold the transformer at the time of installation. It is better to do than to buy. Build your own transformers, making sure of the product quality, saving costs, and expanding your knowledge in electronics. Success!